Hello, and welcome to this third installment of a series of videos about my textbook, Methods of Policy Analysis. In this installment, we're going to be looking at the section of the book that starts to help you build models of the policy process and models of the world so that you can diagnose how conditions have arisen that are seen as less than satisfactory and how you might identify ways to respond to that situation and come up with solutions. So what we're talking about here, and let me share my screen, is starting with chapter 4 of my book, which is specifically about process models and about an overview of working with process models. Um, the first installment of this series looked at chapter 1 of the book, which talks about the nature of policy analysis, doing policy analysis, constraints on policy analysis, goals of policy analysis, and what a policy analysis career might be all about in the way of work. Chapter 2, second installment of this video series, was looking at back of the envelope calculations, which is an important methodological tool that policy analysts use to try to figure out aspects of a policy problem quickly and as effortlessly as possible, especially in circumstances where you cannot collect a large amount of data. So what we're going to be doing here is we're going to be moving on in these new chapters to look at how you actually go about diagnosing a policy problem. We're skipping over chapter 3 of the book, which is an example of policy analysis that uses almost all of the techniques and strategies that are presented in the book to take a deep dive into the problem of reducing the use of nicotine products by the American public and trying to reduce the health consequences that result from the use of nicotine products. That because it uses all the examples and methods that are in the book, I just skipped over that. And the reader, of course, can go back and look at that. And again, there is a link to the book online, which is available to you for free in the description of this video. So now let's start talking about process models and everything that's involved with process models. So I'm going to switch to a different share, and I'm going to share this device that allows me to draw for you, okay? And I'm going to start drawing for you some diagrams that reflect content that's in the book. Let me find where I put my pens down. There they are. Here we go. All right. So first off, we're talking about creating process models. Process models look at how things work in the real world, how processes unfold from one step to the next, and how processes can give us results that we find less than satisfactory. And because we have mapped out how those processes happened, we can come up with solutions. To build a process model, the book points out we need measures. We need things that we can measure. We need measurable quantities. And policy analysis is often about things that we can measure. We need outcomes. We need to be able to measure something about outcomes, and we need to be able to measure something about the precedents that we think contributed to those outcomes. Most of the models that are presented at this point in the book are models that basically move from one stage to another in a sequence. The simplest one looks just like this. And at each stage, let's call this determinist stage, we have a measure of what is happening here. We understand that there are linkages between the stages, and we understand that there are actors involved with motives, with incentives that are contributing to the flow along the stage. And all of that matters for figuring out a sequence. So process models, by the way, are often called sequence models. This is a growing literature in policy analysis. I now see it referred to in various conferences where people are building and discussing these models. And they become very, very important and recognized as a main tool for doing the type of analysis that this book tries to get you to do. So just give me a second. I'm just going to make sure before we move on, talk about a couple other things. First off, I want to talk about causation. So causation is a tricky concept. If you study how causation works in theory, you find out that you have to be careful that our ideas about causation can be flawed, and we can jump to erroneous conclusions because we think we understand how causation works. But in general, I adopt the the description of causation that is offered by Judea Pearl in an absolutely amazing book called The Book of Why. And if you've never read The Book of Why by Judea Pearl, I highly recommend this book to you. It is one of the most important books, I think, written in the last 50 years. And what Mr. Pearl says, Dr. Pearl says in the book, is that to say that A causes B is to basically say something akin to B listens to A. In some way, B listens to A and therefore reacts to A. And in theory, we're talking about a situation where whatever's going on with factor B, it reacts to in some way what changes with A. It pays attention to A. It listens and responds to A. May sound simplistic, but it's actually a pretty profound description as you work it through. And it's the one that I try to use in this book to keep causation relatively simple, right? So sometimes we're going to build models that actually involve notions of causation, but we're going to start out first with these simple sequences and see how far we can get regarding building sequence models. There are a series of types of sequence models that are discussed in the book, and we're going to start out here with what's in chapter 5, which are timelines, more complicated sequences than timelines. Actually, these are really branching sequences. And lastly, exit models, which are sometimes also called funnel analysis. And we'll go through these really quickly here in this introductory video, and I'll go over some examples with you in the time allowed. Okay, let's start with a timeline. I'm going to use an example that's not in the book. There are plenty of examples you can read in the book. I'm going to go into a different one. So we're going to talk about building a timeline model. So the example I'm going to use here is traffic congestion at rush hour. So many American cities, including where I currently reside in Chicago, have terrible rush hour traffic. I think Chicago in fact, just got rated as having the worst traffic congestion in the United States. We're now #1 above Atlanta, Los Angeles, and Washington, D.C., if you can believe that. I've been trapped in some traffic congestion in Chicago, and it can be phenomenally terrible. So the thing is this, remember in chapter 1, we talked about we have a situation which we have deemed less than satisfactory, and we want to diagnose it and possibly find a way to intervene and produce a more satisfactory situation. So we have excessive traffic consumption, excessive traffic. We have excessive traffic congestion at rush hour. And that is right now. That's where we are right now. So it could mean a 1 hour, 2 hour, 3 hour delay in the commute for people trapped in this rush hour traffic on the highways. So that is where we are now, and we know that this is not a great situation because it's taking up huge amounts of time. There's also the burning of fossil fuels, the contributing to global climate change, frustrations, anger on the part of the people in the area. People might even move to other parts of the United States just simply because they can no longer live this way. It can have a variety of very negative impacts. But now what we want to do, and this is what the book counsels all the time, we don't start from the beginning. We start from where we are and we work backwards. So there was a sequence of actions that got us here, okay? And if we look back at a certain point in the past, we see that we went from 3 to 4 lanes on the major highway, okay? And this was because there was considered to be excessive traffic at that time. But if we look back far enough, we can find that we went from 2 to 3 lanes. And this might have been actually sort of when the highway was constructed. So we went from 2 to 3 lanes, we got excessive traffic. We went to 3 to 4, we went to 3 to 4 lanes, we got excessive traffic. And now people are pushing to go to 5 lanes or to widen the highways. Now, widening the highways also can cause widespread disruption in the traffic pattern. It's expensive, and it can also result in the destruction of surrounding neighborhoods, when eminent domain might have to be imposed, houses torn down. It might have very negative consequences on the neighborhoods and on housing prices and other similar issues. But the first thing to note here is that any proposal to widen the highway again has to answer the question, well, we widened the highway before, and before that we widened the highway. Why is it that every time we widen the highway, we end up right back where we started? In other words, this sequence immediately raises a question mark about any proposal to add even more lanes to the highway. If every time we widen it, we get congestion again, maybe we need to think of another solution. So this is an example of just a very simple sequence model, but all over the United States, there are very contentious political and policy debates going on about widening the major highways that are in urban areas like Chicago as the solution to traffic congestion right now, even though the sequences say, the timeline says that every time we widen the highway, we just fill the additional lanes with even more traffic and we don't solve the problem, okay? So that's an example of a timeline model. Now we can have a branching sequence model. Right? Let's use again, just in this example for branching sequences, I'm also going to use that traffic congestion problem. And I'm going to start here where we begin. And I'm going to say there's several sequences we could go down. This sequence here, we will say is do nothing. This is the do nothing sequence. So we stay right where we're at, and the highway stays just like it is. Okay? Here is widen the highway, right? And it has consequences that go this way. Here is encourage mass transit. Let's get people out of their cars. Or we can also encourage not just mass transit, we can also encourage ride sharing. Okay? So this is another option going forward. And then here is another option, which is encourage remote work. Don't commute at all. I'm going to fit another one in here just for sake, which is congestion pricing. Let's impose congestion pricing on the highways, and let's toll the roads and charge people more to drive on them when the roads, when many people want to drive at the same time. Let's also do something else that's been tried, which is let's negotiate coordinated schedules for work, where we try to get employers in the region to have different time frames when workers are supposed to show up so that we can spread out the commute. So the commute will run from 7 to 10, and we'll try to avoid the peak as much as we can. And some employers will say workers work from 7 to 3, others from 8 to 4, others from 9 to 5, others from 10 to 6, and we'll spread out the commute that way. Each one of these has different consequences down the road. And so we have a branching sequence here of things that we might do and what might happen as a consequence of doing it, okay? And we can then figure out all sorts of features of this. There may be different branches that happen down the road. There are examples in the book of doing this, of thinking in terms of branching sequences going forward, okay? And so we just map it out going forward. We have a model before that looks like this. This is good enough to explain how we got where we are. Now we have to figure out a way forward from that point. And lastly, we're going to get to, oops, I just got to turn the paper over, pardon me. Lastly, we're going to get to exit or funnel models. Now, this can both be used to sort of project where we go forward. It can also be used to explain how we got where we are today. Now, a funnel model, it got its name because it's got the idea that many programs that we have for intervening with various issues in our world operate a little bit like a funnel, in that we see, for example, in the case of some social programs, we see a lot of people enter the program at the front side, but we don't see as many come out this way successfully from the other side, and the rest, for whatever reason, fall out of the program. Funnel models are often requested actually by funders like foundations to their grantees to say, tell us, we know that you started out serving this many people up here, but how many people successfully completed the program down here? And what explains the funnel? The book offers another view of this called an exit model, in which you start with 100% of the people that enter the program, and then some successfully complete the program, okay? But many others actually, at different stages in the program, actually exit out, and they fall out of the program. And as they fall out of the program, the number of people who are in the program goes down, okay? Because at each exit, you diminish the participation in the program. I'll do one more here. It looks like this. Do it like that. So we have 100% of the people come into the program, and some of them go all the way through and exit out the other side, but some exit here, and some exit even earlier out here. And we then can look at these, not only just the numbers of the percentages that are exiting, but we also can try to explain why they're exiting. And notice if this is 100% of the cohort that comes in the front of the program, then we can actually see the cut down in the percentages by the thickness of these bars. It can actually be used to represent what's actually occurring here. And then you can look at the breakdown of different groups, which the book has an example. So let's take as an example from traffic again. Let's say that we try to encourage people to engage in mass transit and rideshare instead of take their car. And this is 100% of the people who agree to sign up for some type of program that will encourage them to use mass transit or some other means to get to work and not drive. And what we see is that after having signed up, early on, some of them bail out right away and go back to their car. Later on, others bail out and go back to their car. And some stick with mass transit or commuting and continue to do that. And we want to know, why did you get out? Why did you stop? And there can be a lot of factors that we identify as to why people got back in their cars and began to contribute again to traffic congestion. I've encountered many of these myself personally, maybe you have. The examples can include such factors as realizing that you have to get to your children in the middle of the day if they get sick or have to exit school, and you feel you're far away from that location where the school is. Let's say you're in downtown Chicago and you live in the suburbs and you have to get back out there. If you have to rely on mass transit, you have to rely on rideshare, you could get stranded and cannot get to your children, can be a factor. There may be something else that changed in your life circumstance that says this just isn't working. You discover that the costs of mass transit and rideshare are actually, you perceive them to be higher than using your own vehicle, and you don't have as much flexibility. There's all sorts of reasons that can contribute there. If it turns out it's about the expense of mass transit and commuting, then of course the obvious solution is to find a way to reduce those expenses and get people to change their mental calculus regarding their economic calculus regarding the costs of commuting, and they'll switch back perhaps to mass transit, improving the mass transit system so it is cleaner, more efficient, faster, more reliable. And in the case, for example, of parents who realize that they need to get back to their children on short notice, some communities have actually offered emergency rideshare programs. In the advent of a school emergency or a child emergency, then they can get you like an Uber or a Lyft and get you right back to your children right away to take that pressure off of you to think that you just have to have your car in case something happens. So these are examples of sequence models that can be used both to explain how we got a situation that is less than ideal in the view of the client, and also to think about looking forward in terms of solutions. Sometimes the same model can be used for both purposes. Other times, one model gets you an understanding or a diagnosis of the problem. Others of these sequence models push you further down the road. So that's just been a very, very quick look at how all of this works in the book and the discussions of timelines and sequences. I encourage you to read through the examples that are in the book, familiarize yourself with them. There's some really interesting cases, some of the classic cases taught in our field, for example, involving preventing foodborne illness and people dying from illnesses that they get from eating. There's other examples that run the gamut of things like legalizing cannabis products and other similar issues. So please do read the book, work through those ideas, see how they work. One last thing I will address before I stop here is that I do know a lot of students find these models, these sequence, timeline, exit type models to be simplistic. and they're worried that it's a very simplified view of reality. But as it says in the book, I'd rather have a simplified view of reality that actually takes me someplace useful for doing analysis than a very complicated version of reality that actually doesn't contribute to the conversation. And I found numerous instances where these timeline models, these sequence models, make a huge difference in the conception of a problem. And if you read the example of food safety, you will see that a large amount of the apparatus that the United States has built to try to keep people from getting sick from eating meat that they bought to cook at home. And that apparatus involves monitoring the animals at the time they're being raised and slaughtered, and then the meat transported to market. All of that does not do a lot of good if the consumer does not follow strict safety protocols regarding the handling of the meat. They can still get ill, no matter how hard you try to prevent them from getting ill. It's just an example of a model that has an effect like, as a positive benefit like that for our policy analysis. Thank you very much for your attention to this video. Hope it gave you a good overview of chapters 4 and 5 of the book. Please do read them. Again, there will be there's a link in the description for you to access the book if you need, and I will have the next video in the sequence will be up for you to watch that has to do with the following chapters on building different types of sequence models. Thank you so much.